name is Maksut Taşpınar. I am studying my master's degree at Civil Engineering Faculty of Yıldız Technical University and currently working in Opal Steel Construction Company as in a project department and also manufacturing responsible. Our topic is investigation of connection members behaviors of steel in parametric solutions. In parametric manner, we try to understand and we try to model our problems and try to solve them in this way. In the content of my presentation, first of all, I will talk about structural steel, structural design, steel materials, steel sections, advantages and disadvantages of steel structures, as we all know, and obtaining the behavior of steel with experimental methods. First step, abacus, because we used in our models abacus program in our studies, and then we compared our study with experiments that has been done before, and parametric study models I will show you, and then I will show you some analysis and results. I don't have now all the results yet because our project is still going on. We still continue to produce solutions and results, so it's still like at its first steps as a baby. Yes, structural design. As we all know, that the determination of sizes in steel structures is like a loop. First of all, we assume. We have some sections, we have an idea of a building, and we assume some materials, some sections that will carry our building. Then we start our structural analysis. We make our structural analysis of the main building, and then we make structural analysis of the connections, and then we determine, and then we get the assumption, we compare the results, and after that, if it's different than what we assumed, we assume again, we have assumption again, and if no, we go to final stage. Yes, as we all know, when we are designing something, especially our topic is about connections. Not all the building, but our main focus is connections. So when we design a connection in steel structures, we shouldn't put unnecessarily bolts. We shouldn't make the thickness of plates unnecessarily big. That's why economic and usability and strength is important. That's why, as we all know in steel structural, all structural designs, these three steps are very important. Structural steel, as we all know, steel is made of iron most of all, and then we add carbon atoms and then other elements to strengthen the material higher. If the carbon is more, then the material has more power, but it's ductile. So we try to make it in optimum way, and if we want to make it more powerful, we can add also other elements, other metal alloys, as it's shown here. Yes, as we all know, in oxygen furnace, we combine oxygen and other waste and other steel waste and lime and alloy, all these materials we combine, and then we get melted steel, cast, and then shaping as we want. It's eye, edge, or plate, whatever we want. Yes, advantages of steel. Advantages of steel is so many. Here I try to write some to get the idea. Just as it's written here, it's like homogeneous and isotropic material, and it's most of all it's designed and it's under control, not like others. We can add as much as we want, the materials we want. Yes, it's self-weight over useful load is low. It means that in a smaller section we can get higher strength, not like in concrete. In concrete, with the same strength, what we want, we need to make maybe bigger shape. But with steel, in a smaller section, we can get a bigger strength. Yes, and also manufacturing takes place in closed areas, so it means it's not affected by weather conditions like in others, like in concrete. The concrete comes to the site and we pour it to the field, and if it's rainy, if it's snowy, it can be problematic. But with the steel, it's not like this. Because production is always in closed areas, in closed facilities. That's why it's not affected by many problems as other materials. And what is also advantage that it can carry loads immediately after assembling. So it's time saver. But what about concrete? In concrete, it's not like this. Okay, I will not continue with that so much because this is all civil engineers know about this. And disadvantage, the biggest disadvantage is that it's not flammable, but it loses its strength on very high temperatures. Like as in this photo, we see it's this skyscraper but collapsed. Twin Towers in the United States of America after the plane crash. It actually collapsed because of the heat that the beams, that the columns lost its power. Yeah, and the other problem is the corrosion problem. So it needs care in high-rise buildings. Most of all, they put cementitious paints. It's cement-based paint to cover the steel against corrosion and also against the fire. So that's also used. And then other problems that can be like cracks, micro cracks can turn to macro cracks, and it means at repeated loads, like it can be a factory building, etc. It can be problematic, so it needs to be under control. Yes, usage of steel structure, each span needed warehouses like steel structure buildings, spans can be made, even like 60-meter spans can be made with steel structure, as it cannot be with concrete, for example. So like stadiums, like big hangars, warehouses, like plane hangars, etc. can be done with steel structure like no other material. On weak foundations, high-rise buildings, industrial buildings, which we mostly use, which we mostly deal with steel structures, and fastly needed buildings because it's faster than concrete if you compare, and as I told you, like it can carry loads immediately after the assembly. So in concrete you need to wait some days to continue other flats, but in steel structure it's not like this. Yeah, as I was showing in the beginning, we get the melted steel and then we can shape it as we want. European sections and other countries' standard sections can be made in any shape we want, in any shape that we desire to make our structure. Here are just some common sections that we use at our buildings mostly, just some common sections. I'm passing here this stuff faster. Yes. Why it doesn't play? Let's play normally. Yes, could you press it please? Yeah, it's animation, but anyway, it doesn't use. It doesn't. Okay, anyway, here we use Abacus program to make these designs, and we made tensile to get the yield stress of the material to design our structure. So as in reality that it's used to characterize the material, we look at the yield, we look at the this characteristics. So we did exactly this in Abacus to obtain the material, because in Abacus program that we use, it's very important that you need to write the right material. It's like a keyhole with the key. If you don't have the key, you cannot open the door. So it's exactly like this. So that's why we try to get we try to get the exact material that we will use in our problem. Because otherwise we will get some solution, we will obtain some answers, but it will not be as it should be, because we didn't define the steel, and then otherwise we will not see the crack maybe, we will not see the yield maybe. So that's why the material should be written in the code language that we did right way. Yes, for comparing our model that we did we studied some experiments that has been done before. Here you see some photos that also I will show you that, as I told you, we work on connection of steel. So here in some connections, after some load, we obtain some results that we face. So there are so many studies about that, but we just add parametric study that I will tell you about. So these were that we used their result to compare with our model. Yes, so many graphics, so many like here like triaxility, here as we know stress graphs, displacements of the material, in which grade, in which point. So this was important to model our steel. That's why I wrote this. Yeah, here are some words about Abacus. That Abacus is very powerful program, not to just use steel. Even like you can model a heart, you can model a body part with that. There are some programs like this, like ANSYS. I'm sure you know ANSYS program. They are finite element model solver programs. But to be honest, we didn't use Abacus to model our problem. We didn't use this one to model. We used Python program, maybe you know. It's the coding language. We wrote in Python our codes. So after that code, we wrote in a way, in automated way, that we changed there some like steel thickness and like bolt sizes, diameter holes, etc. Whatever we write in Python language, it automatically comes to Abacus and it solves, and then it gives us the results. Because Abacus is very powerful program, very whatever you write, you will get as much as you give, as much as this you will get. So it's such a program, but modeling is a little difficult in this one, like because it takes so much time. That's why we used in our parametric study coding language to make things faster. Otherwise, I will show you, we use 270 combinations of different types. If we wanted to draw all of them, it would take maybe, I don't know, maybe 2 years or something. But in automatic way, it took 1 week. In one week, in 270 combinations were solved thanks to Python, thanks to this code that transferred to the Abacus. I will show you more. Yes, Abacus program, as I was telling, can solve linear and non-linear analysis, dynamics, frequency solutions, buckling solutions, dynamic response, frequency response, geostatic solutions, heat transfer, electromechanics, underwater blast, car crash. As I tell you, even more than here, like you can shape a body part or something and get the result. Once I was looking on internet and tried to get some things, I even saw someone modeled a heart, a bumping heart. Modeled was in Abacus, which was interesting. Yes, here first of all I will show you like first steps in Abacus modeling manually. As I told you, we did in Python language, but here I